So given that we started with coding things as 0 and 1, it might be natural to think, well, maybe we could just add a 2. We could code the variables as 0, 1, and 2. And it turns out that if you do that, you are enforcing too much structure on your data, right? And what do I mean by that? Well, we know from grade school that the difference between 1 and 0 is 1, and the difference between 2 and 1 is 1, right? It's the same difference. It's a difference of 1 either way. When you code things as 0 and 1, 2, 3, 4, you could go on, you would be assuming, especially in this case, that the differences between the levels are the same, and there's not necessarily a natural ordering to them, so that sometimes doesn't make sense. In this case, we would be assuming that the difference between spring and summer is the same as the difference between summer and fall, which I, for one, don't think is accurate, right? So summer, there's lots of people that are outside, lots of people having free time, so my guess is that because it's got the nicest weather and among other things, summer would be a time where there's lots of people out and maybe fewer people are out in the spring and fall. Okay, so we can see too here in our model that it's not significant, right? We've got a p-value of 0.32. We also got this slope, so let's think about what this slope would mean. Well, if spring is 0 and summer is 1 and fall is 2, this means that going from spring to summer, we would see an expected increase of 63, and going from summer to fall, we would see an expected increase of 63. And again, that doesn't make sense, especially if you're talking about late fall, starting to get into winter, there's going to be a drop. So we shouldn't be using this method to go about including categorical variables with more than 2 levels in our model. What we instead want to do, we just went over that so you can follow along. This is slide 11. I just talked about that. What we instead want to do is fit a regression model with k-1 indicators. Okay, so if we've got a categorical variable that has k levels and k is more than 2, you want to add coefficients or indicator variables for k-1 of those levels. Okay, the last level doesn't need a coefficient. It's already incorporated into your model because remember the intercept stands for the expected number for the baseline. We also sometimes call that as the reference level. So it's already in there. You don't need to add another categorical indicator variable, right? Once we have this reference level, we are considering all of the coefficients to be relative to the reference level. So I've written out what my model would be here, and you can see I have the expected number of riders or users is equal to the intercept plus B1 times summer plus B2 times fall. Okay, let's look at what that looks like. We're starting to see the p-values still aren't significant, but they're starting to get there. So it does tell us that this is a lot more informative. It's better for the model to fit these things this way. Now we can interpret our estimates. So in this case, let's first think about what the reference level is for the season. This is on slide 13. You can tell that the reference level here is spring because it's not mentioned in the code. We see summer, we see fall, so spring is what's left over. That's the reference level. Okay, the reference level sort of belongs with the intercept, so we can see that in spring we expect 371.66 users on the rail trail. Now, the coefficient for summer is 50, so in summer we would expect 50 more people on average to be using this rail trail relative to spring, right? Spring is the reference level, so everything is relative to the reference level. In fall, we see a coefficient of negative 76, so in fall we would expect 76 fewer riders relative to spring. Okay, and we can see there that's way unlike our first model that we fit with zeros and ones and twos, right? You see an increase for summer and a decrease for fall relative to spring. And that, hopefully to you, makes a lot more sense. It makes a lot more sense to me. Okay, so that's how we include categorical variables with multiple levels. We use multiple different indicator variables. And you can already see here, I kind of did it without really telling you. We were thinking about one variable, we were thinking about season, but we already have two predictors inside our formula, inside our regression model. So we're going to talk about what happens and how to work with these models with multiple predictors, even though we've already seen this one, in the next video.